Hello guys, so in this video what I want to go over is some very common algebra mistakes that I've seen students make so many times. And also usually this is also including some trigonometry mistakes. I will make a kind of a part two to this because I want to go over some basic algebra mistakes that I've seen students make so many times. And things that students tend to forget about, just arithmetic and, some common algebra mistakes that kind of, that basically make it very difficult, in calculus, right? That we just, these are the mistakes that make calculus very difficult if we don't know them. So the number one mistake, and this is the first error, the first math error, is division by zero. Now, a lot of students believe that if I say 2 divided by 0, that this is equal to 0. No, this is not true. If I literally divide 2 and 0, what times 0 gives me 2? There is nothing that gives me 2 when I multiply by 0. Everything multiplied by 0 is 0. So what we say to this when we say 2 divided by 0, this is undefined. We always say that's undefined because we do not know what that is. It's just something that in math that we do not know what it is. Now, if we multiply 2 times 0, well, this is 0. And if I say 0 times 2, then this is 0. Also, guys, 0 over 0 is also undefined. We do not know what that is. We really don't. So these two things we have to know very well. And this is a mistake. This is like the number one mistake I see students make all the time as a tutor. Like when I tutor students, I see them make this mistake all the time. And of course, these mistakes that I'm listing are mistakes that drive teachers and professors, if you're in college, crazy. So if you make a mistake like this in calculus, your professor's going to be like, oh boy. So we have to remember that rule that division by 0 is not possible. However, if we say 0 divided by 2, then that can work because it's just, 0 divided by 2, 2 times 0 is 0, and we're done. But we cannot have it in the denominator. The way I like to remember is that when we have 0 over 0, this means, oh no. So what do we say to that? This is undefined. We don't know what that is. Now, a number on top and 0 on the bottom is also undefined. So just be very, very, very careful with that. So that is the first one. Now, this is yet another error that I see students make all the time. When we square a number, so for example, if I say, let me say, for example, -4 squared versus the quantity, parentheses, -4 squared. So a lot of students get these mixed up. They get these mixed up all the time. And, of course, it's very common, but we have to remember the difference. So a lot of students tend to think that -4 squared is 16, or that this one is -16, or, that this one is 16 and this one is 16. Basically, we have to know the difference, right? When we have, so negative, and let's do a squared, right? This is really negative 1 times a squared. So when I talk about this, I would say this is considered negative 4. So negative 4, let's do negative 4 squared, which is really just negative 1 times 4 squared. And this is considered negative 1 times 16, which is negative 16. So this is actually negative 16 and not 16. So do not say that negative 4 squared is 16, because this is not true. Now, if it does have parentheses, this is why the parentheses are so important, because they basically say that negative 4 is all squared. It's being squared. So when it's on the outside, this is really said as negative 4 times negative 4. And this is equal to 16. Okay, so we have to know the difference. Also, the idea of cubed roots, right? When I say negative 3 cubed, or let's actually do negative 2 cubed. This is considered negative 2. So it's really considered negative the quantity 2 times 2 times 2. So we have to understand that difference. Otherwise, we're going to get it wrong. And also, a lot of people tend to think that that negative 2 cubed is 8. It's not. When a negative is cubed, it's negative. So even if I say negative, so even if I say this, for example, this is still negative 8. If I say this is still negative 8. So they're the same thing, but for squared terms, they're not. Okay, one is negative and the other is positive when it comes to squaring. So we have to be careful. So that is yet another error, right? Okay, so another error that I want to emphasize, and this is yet another error that I see students make all the time. We have to understand the rules of, adding, subtracting, multiplying, and dividing negatives. So I always like to pinpoint and list out the difference between, when we're subtracting 2 negatives or adding 2 negatives, or all the rules, or like multiplying 2 negatives, dividing a negative by a positive, all that stuff. And I'm going to go over this, right? So a lot of students, I feel like they make this mistake so much, where they either believe that, for example, if I have negative 2 minus 3, this is like if they say either it's 1 or negative 1 or 5. None of these are the answer to this, okay? The idea is that when we have negative a minus b, we always, I've learned a certain rule called keep it. And then let's do this. Hold on, let's do change it. And then opposite. This is going to be opposite. So for example, if I have negative a and I have a minus, and then I have a b over here, right? I'm going to keep my my negative a. I'm going to keep my negative a. I'm going to change the negative to a positive, and I'm gonna do the opposite of b. The opposite of b just means, if it's positive, it'll become negative. So really, this becomes negative a plus, and then it'll be negative b, right? So we have to remember that stuff. So when I do negative 2 minus 3, well, like I said, it's negative 2, and I have minus, and then I have a 3. Well, this just becomes negative 2 plus, and I'm going to do negative 3. Now, obviously, two negatives are being added here. So if I have, and I'm going to do a t-chart, let's say I have negatives here. I have two negatives, right? Let's just kind of color code here. I have two negatives, and then I have also 3 other negatives, right? And I know that I'm adding them together. So how many negatives am I going to have? How many do I have? Do I have positives or negatives? Well, I'm going to count them. 1, 2, 3, 4, 5. So I have 5 negatives. So that means negative 2 minus 3 is negative 5. This is so important, guys. This rule, if you know how to do this rule, it's gonna make it a lot easier. And it goes for all of the arithmetic, like all of the, the adding and subtracting negatives. Another rule that I see students make another mistake I see students make all the time with arithmetic specifically is the idea that that if I do a negative over a positive, that this is either positive, like it's going to be positive, or that a positive over a negative is positive. So neither of these are right. For example, if I say negative 6 over 2, a lot of students think, well, that's 3. But no, it's not. It is not 3. It's negative 3, okay? It's negative 3. So a negative over a positive is negative. So this is the correct way to do it. That goes the same way for positive over negative. So when I say positive over negative, it's still negative, right? So this again is the correct way to do it. So we have to see the difference. Also, if I divide two negatives, so let's just say I divide two negatives, this is a positive, okay? Of course, a positive over a positive is a positive. This is one that students obviously know right off the bat. But these other ones are ones that I see students make all the time. And when I say, what is negative 6 divided by 2? They say 3. And I'm like, negative or positive? They're like, positive. And I'm like, no, it's not. It's negative. Okay, so we have to remember that rule. And let's see. Oh, and this goes the same way for multiplying. So when I say negative times a positive, this is a negative. If I say negative times a negative, this is a positive. If I say negative or positive times a negative, this is a negative, okay? It goes the same for multiplication. So like if I say negative 2 times 3, this is negative 6. If I say negative 2 times negative 3, this is 6. If I say 2 times negative 3, this is going to be negative 6. So we have to remember those rules. Otherwise, these are just very simple algebra mistakes that students make all the time, and we have to be careful. Okay, so that is yet another rule. Now, Another rule that, or another mistake, another error that students make all the time in algebra is the idea that um, if I say, for example, 2 times x minus y, that this is automatically, like, basically they don't distribute it all the way through. So for example, if I am talking about, so let's see, if I am talking about distributive property, and I say, well, this is gonna be 2x, right? It's gonna be 2x minus y. And this is not true. It's not correct. And the reason why they make this mistake is because they think that 2 times u is 2u, which is true, but remember, this entire thing is being multiplied by 2, so we have to distribute it all the way through. This means that we're going to get 2x minus 2y, okay? And this kind of goes along also with the idea that when I say negative 2 times x minus y, students tend to forget that they say negative 2x minus 2y. But if you look very carefully, there's a negative here, and when you distribute that negative 2 in here, that is going to become a positive. So we have to be careful with that because it's just so important. We cannot make that mistake. So if you think about it, negative a times b minus c is really negative ab plus negative a times negative c, which is negative ab, and then plus AC, because this becomes a positive, remember, because negative times negative is positive. So this is our answer. So that is kind of another huge, like, very common error that I see students make in algebra. All right, so this is another mistake that I see students make constantly. So this is kind of the idea that, so when I say a, so let's do a plus or minus b all over c. Students tend to believe that this is equal to a over c plus or minus b. Or actually, well, yeah, this is one of them. Another one is that they think that a plus or minus b over b, they think that this cancels out and that this is just considered a, or either a or a plus 1, because the b becomes a 1. No, guys. No. We have to be careful with this, and I cannot stress that enough. If I say, for example, 2, and let me, hopefully this kind of fixes itself. 1 second, guys. All right, so we have to be careful, guys. No, this is not correct. So, for example, if I say 2 plus 3, let's just do 2 plus 3 over 3. And I'm gonna, if I make this mistake, I'm gonna be saying, well, this is gonna be just 2. But is it though? Is it really 2? If I add 2 plus 3 on top, that gives me 5. So this kind of becomes a 5, and then I have over 3. But is 5/3 equal to 2? Is it? No, it's not. That goes the same with negative, so like with minus. If I say 2 minus 3 over 3, I look at this and I'm like, oh, cancels out. Like, it just becomes, it just becomes 2 minus 1, because we still have a negative here, and that just becomes 1. No. 2 minus 3 over 3 is negative 1 on top, because negative 1, that's what goes on top. And on the bottom, it's just 3, so it's negative 1/3. This is not equal to 1. We have to be careful, okay? Yeah, that's kind of the idea. And also the one for the a plus or minus b over c. So for example, 2 plus 3 over 4 is 2/4 plus 3 over 1, or 2/4 plus 3, right? If I look at this and I'm like, oh, well, it's really 2/4. It's really 2/4 plus 3. I'm like, it's 1/2 plus 3, which is really, 1 plus 6 all over 2, which is 7 over 2. But no, this is basically, the top is 5, so we know that this is 5, and the bottom is just 4. So this whole thing is 5/4. But this is not equal to 7/2. No. So obviously, this rule, it just, no, we do not do this. We do not do that. We have to do what's on the top and then, do what's on the bottom. You can say 2 plus 3 over 4 is 2 over 4 plus 3 over 4. That is okay to say because they have the common denominator. Another thing I want to say about this is the other way around. If I say 4 over 2 plus 3, a lot of people think that this is going to be 4 over 2 plus 4 over 3. No. If I actually work this out and I say this is, well, 4 over 2 plus 4 over 3, this is 2. This is 2 plus 4 over 3, which is really just 2 over 1 plus 4 over 3. I get my common denominator. This is 6 over 3 plus 4 over 3, which is really 6 plus 4 over 3, which is 10 over 3. But 4 over 2 plus 3 is really 4 over 5. But is that equal to this? No, it's not. This is not, they're not equal to each other. So we have to be careful. We have to be careful, guys. There's a difference. So I really want to emphasize that. And that is one of the mistakes that so many students make. Like, they make that mistake so much. And you have to understand how fractions work very well. So yeah. Okay, this is yet another error, guys. This is so common. A lot of students tend to think that because two radicals are being added, that you literally have to just add the numbers and make it into one radical. No. I'm gonna give you guys an example. So the square root of 9 plus the square root of 4. Let's just kind of do that. And what if I say this is equal to the square root of 9? Square root of 9 plus 4. Now, the square root of 9 I know is 3. the square root of 4 I know is 2. So 3 plus 2 is 5. But is this equal to the square root of 9 plus 4? Well, the square root of 9 plus 4 is really the square root of 13. But are these equal? Are these really equal? No, they're not. The square root of 13 is a decimal, and that is not equal to 5. So we can't say this. This does not work. When you're adding or subtracting square roots, you have to be careful and not think, like, you cannot believe that that you just add, you make it into one radical and then add them. No, you do not do that. Also, another error that I see students make is the idea that the square root of, for example, -4 is equal to -2. No. The square root of -4, anytime we take the square root of a negative number, this is not a real number. So we have to be careful with that. In algebra, you learn actually that the square root of -1 is I, and I is going to be a complex number. But I don't want to make this video too complicated. But we cannot say this either. We cannot say that the square root of a negative is just a negative, because it's not true. You can say negative the square root of 4 is equal to -2. That can work. But you can't say the other way around. Also, when you take the cubed root of a negative number, like, I don't know, -27, you cannot assume either that this is not a real number, because if you think about it, this is really -3. -3 times -3 times -3 is, so this is going to be 9 times -3, this is -27. So this can work. When it's cubed, when the nth root is odd, you can take the square root of negative numbers. But when it is even, such that, you know, it's the square root, where it's a little 2 here, and I say -4, this can't work. So we have to know the difference. So this is going to be considered part 1 of some common algebra mistakes that I have seen students make. So that is going to be it for this video, guys. So if anybody has any questions, or if you want to, you know, if you have any other like common errors that you've seen, please let me know. But I really hope this kind of gives you some insight as to, you know, what algebra mistakes you need to be aware of, and what, you know, math errors that we all need to be very, very aware of and be very careful with. So I really hope this helps, guys, and thank you so much for watching, and please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.